Welcome back to Mr. Vaughn's classroom, where math is made easy. Today we're looking at Unit 6, Introduction to Quadratic Functions, Lesson 14, Graphs that Represent Situations. The learning goal today says let's examine graphs that represent the paths of objects being launched in the air. We have one learning target today. At the end of the lesson, we'll come back, review this, and make sure you've learned what you need to before moving on to the next lesson. Our learning target today says you can explain how a quadratic equation and its graph relate to a situation. Practice problem number 1 says here are graphs of functions f and g. Each represents the height of an object being launched into the air as a function of time. Number 1 asks us which object was launched from a higher point. So if I want to know launch height, I am talking about the y-intercept. So I'm comparing the y-intercept of function f, which is the green line, so this bottom red point, with the y-intercept of function g, which is the blue line, and it's this top y-intercept. Since function g has a higher y-intercept, that means function g was launched from a higher point. Number 2, which object reached a higher point? If I want to know about the higher point, then I am comparing the vertex of each one. So it looks like the vertex for function g is right about here where I put this blue point, and the vertex for function f is right about here where I put this higher blue point. Since function f has a higher vertex, that means function f reached a higher point. Number 3, which object was launched with a higher upward velocity? So if I want the launch velocity, I'm talking about how steep is this initial upward side of the parabola. So what I'm really comparing is the steepness of these two lines. And the steeper the line is, the more up and down the line is, the higher the velocity of the launch. So since f has a steeper initial line on the parabola, that means function f has the higher launch velocity. And number 4, which object landed last? If I want to know when they landed, I am looking at the x-intercept. Because what I see, function f is launched, it goes up higher into the air until it hits its vertex, and then it comes back down and it hits the ground at this x-intercept. Function g launches from a higher starting point, goes up slightly until it hits its vertex, which is lower than function f's and slower, and then it falls back down and it hits the ground at this later x-intercept. So that means function g landed last because more time had passed before it came back down to the x-intercept. So we know that function g had a higher launch point and it landed later. And we know that function f reached a higher point and it was launched with a higher initial velocity. If you have any questions about how to interpret the characteristics of a graph to answer questions, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 2 says technology required, but the only technology we really need is a basic calculator. The function h given by h of t equals the quantity 1 minus t times the quantity 8 plus 16t. This models the height of a ball in feet t seconds after it was thrown. Number 1 wants us to find the zeros of the function and show or explain your reasoning. So if they want the zeros, remember that means the x-intercepts. And the reason that they had said technology required is that one way you can do this is to take the original function they gave you and put it in the Desmos graphing calculator and just see what your x-intercepts are. The other way that you can do this is simply by taking each factor, since this is given to you in factored form, setting that factor equal to 0, and solving for t. So first we have 1 minus t equals 0. We add t to both sides, and we get 1 equals t. Next, we can take 8 plus 16t and set that equal to 0. We subtract 8 from both sides, and we get 16t equals negative 8. Now we divide both sides by 16, and we get t equals negative 1/2. So now we found the zeros of the function. Number 2, what do the zeros tell us in this situation? Are both zeros meaningful? Well, the zeros are giving us a time. And the time for an x-intercept would mean the time when the ball hit the ground. So the times when the ball hit the ground. And since we're looking at when the ball hit the ground, the only one that makes logical sense is the positive one. T equals 1 says the ball hit the ground 1 second after it was thrown. T equals negative 1/2 says the ball hit the ground half a second before it was ever even thrown. So that's what we put. The positive time is the only one that's meaningful. The ball hit the ground 1 second after it was thrown. Number 3. From what height is the ball thrown? Explain your reasoning. Well, if I want to know the height, then what I want to do is turn the factored form into standard form, because the C term in standard form tells me the y-intercept, which would be the starting height. So 1 minus t times 8 plus 16t. 1 times 8 is 8. 1 times 16t is 16t. Negative t times 8 is negative 8t. And negative t times 16t is negative 16t squared. I combine the like terms, and I'm going to reorder it into ax plus bx plus c. So we have a negative 16t squared, then 16t minus 8t leaves us 8t plus 8. And this term right here, the number only, the C term, is the y-intercept, since it is measuring height in feet, that tells us the ball was thrown from a height of 8 feet. And number 4, about when does the ball reach its highest point, and about how high does the ball go? show or explain your reasoning. So what we want is the vertex. So to find the vertex, I'm going to take my two x-intercepts and I'm going to combine them. 1 minus 1/2. And then I'm going to divide that by 2. 1 minus 1/2 is 1/2. And 1/2 divided by 2 is 1/4. So I know that my x coordinate is 1/4. Now I need to take this 1/4 and I need to plug it into my equation. So I have negative 16 times 1/4 squared plus 8 times 1/4 plus 8. 1/4 squared is 1/16 times negative 16 is negative 1. 8 times 1/4 is 2. And then we have plus 8. Negative 1 plus 2 is 1. And 1 plus 8 is 9. So my vertex is at 1/4, 9. That means the height is 9 feet after 1/4 of a second. That is our vertex. If you have any questions about solving any part of this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 3. The height in feet of a thrown football is modeled by the equation f of t equals 6 plus 30t minus 16t squared, where time is measured in seconds. So this is what we call projectile motion. And projectile motion is modeled by quadratic equations. So what we have here is 3 parts. The t squared portion is gravity, pulling the object towards the earth. The t term represents the initial velocity. And the constant represents the initial height. So using this information about how to read a quadratic equation that is representing projectile motion, we can answer these questions. Number 1, what does the constant 6 mean in this situation? Well, right down here, I told you that the constant is representing the initial height. And we can see up here that the height is measured in feet. So that means the football was thrown from 6 feet high. That was the initial height of the football. Number 2, what does the 30t mean in this situation? Well, we said that the t represents the initial velocity. T is measuring seconds, and the 30 would represent feet. So this means the initial velocity of the football was 30 feet per second. That's how fast the football was thrown. And number 3, how do you think the squared term negative 16 t squared affects the value of the function f? What does this term reveal about the situation? So negative 16t squared represents gravity pulling the ball down to earth at 16 feet per second per second. That is the acceleration of the ball towards the earth caused by gravity. Now, we'll see a bunch of these projectile motion problems in the unit, and the format will always be the same. The constant is always going to represent the initial height. The bx, or in this case, the t term, is going to tell you the initial velocity of the object. And the ax squared, or in this case, t squared, is going to be representing gravity pulling the object toward Earth. If you have any questions about this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 4. The height in feet of an arrow is modeled by the equation h of t equals 1 plus 2t times 18 minus 8t, where t is seconds after the arrow is shot. So again, this is going to be a projectile motion problem. So number 1 wants to know, when does the arrow hit the ground? Explain or show your reasoning. So if I want to know when the arrow hit the ground, then what I'm looking for are the x-intercepts. So set each factor equal to 0 and keep the one that is positive. So we have 1 plus 2t equals 0. We're going to subtract 1 from both sides. That gives us 2t equals -1. Then we divide both sides by 2, and we get t equals -1/2. That means the arrow would be landing half a second before it was even shot. That one doesn't make sense. So let's use the other one. 18 minus 8t equals 0. We add 8t to both sides. And we get 8t equals 18. Now we divide both sides by 8. And we get t equals 18 over 8, which simplifies to 9 over 4, or 2 1/4 seconds after it was shot. So that's when the arrow lands. Now number 2 wants to know from what height is the arrow shot. So what we're talking about here is the y-intercept. If I want to know the y-intercept, then that is the constant in the standard form. So if I want the constant, then I can simply multiply the number from the first factor times the number from the second factor. So 1 times 18 equals 18, and this is measuring feet. So that's 18 feet above the ground. That's the starting height of the arrow. Now you could multiply both of these factors together, get it into standard form, and then pick out the constant. But if you understand how these go back and forth, there's really not a need to. What you need to understand that is, if you multiply the t term by the t term, you're going to get the t squared, which is your gravity. If you multiply the numbers times the t terms, then you're going to create the t term, which is going to be your initial velocity. And if you just multiply the constant times the constant, you'll get the c term, which is your initial height or your y-intercept. if you have any questions about this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Our last practice problem says two objects are launched into the air. The height in feet of object A is given by the equation f of t equals 4 plus 32t minus 16t squared. The height in feet of the object B is given by the equation g of t equals 2.5 plus 40t minus 16t squared. In both functions, t is seconds after launch. Number 1, which object was launched from a greater height? So, if I want to know about the launch height, then I'm talking about the y-intercept. And in this case, that is my c term. So for number 1, object A launched from 4 feet above the ground. Object B launched from 2.5 feet above the ground. So object A was launched from a greater height. Number 2, which object was launched with a greater upward velocity? If I'm talking about the upward velocity, now I'm comparing my bx term. So, object A had an initial velocity of 32 feet per second, while object B had an initial velocity of 40 feet per second. This means object B had a greater upward velocity. If you have any questions about how to relate the parts of a quadratic equation with the parts of projectile motion, please leave a comment below and I'll get back to you with any help that I can offer. Before we end this lesson, let's go back and review our learning target and make sure you know everything you need to before we move on to a future lesson. Looking back at our learning target, it said that you can explain how a quadratic equation and its graph relate to a situation. In these practice problems, we were looking at projectile motion. Projectile motion is represented by the equation because the ax squared term is representing gravity pulling the object back to Earth. The bx term is representing the initial launch velocity, and the c term is representing the initial height. When we look at the graph, we see that the y-intercept is representing the initial launch height. We see that the vertex is representing its maximum height. And we see that its x-intercept is representing when the object lands on the Earth. If you have any questions about relating quadratic equations, their graphs, and the projectile motion of objects, please leave a comment below and I'll get back to you with any help that I can offer. On your screen, you should see a video that YouTube believes will be helpful to you. If you did find this video helpful, I ask that you hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next lesson.